Okay, so here's number 18 in the section in your workbook. So it's a graphing question. So we have a lab question. We have a neodymium magnet. It says that this magnet is 1.2 centimeters in diameter. So that's probably important information for later. It says the balance was zeroed off. So it starts at 0, 0 because the balance was zeroed off. And then as we increase the current, the balance reading goes up. Now, if we think about what a scale actually measures, the scale is measuring the force of gravity. And if we've zeroed it, that force of gravity is the thing that it is measuring now is the magnetic force. So the force of gravity is mg. The magnetic force is ILB. So we want to find the slope of the graph. I find it easiest probably to put it in slope-intercept form. So to find out what the slope actually is. I guess I know the slope. I have that value there. Okay, so I have 3 amps and 1.1 times 10 to the negative 3 when I graph it. And I'm going to use 0, 0. It always feels like cheating. But it's nice when it goes through 0, 0, and it should. So rise 1.1 times 10 to the negative 3 divided by 3 amps is, I get 3.6 times, 3.67 times 10 to the negative 4. So pretty close. So approximately, I guess, to 2 sig figs. So that would be 3.7 times 10 to the negative 4 is what I get for my slope. Then it has to use the slope to determine the strength and magnetic field acting on the wire. So we have this relationship. My balance reading, so my mass, the thing that my balance tells me is the mass is on my y-axis. So that's my responding variable. My x is current. So I need to rearrange this equation into y equals mx form. So I'm going to divide by g. So I have mass is equal to L times B divided by G times I. So in slope-intercept form now, here is my y, here is my x, and then this whole term is my slope. So this 3.7 times 10 to the negative 4 is equal to LB times G, what my slope actually represents. So I can take that number. I still have all the decimal places, so times G, so times 9.81, divided by L, so 1.2 times 10 to the negative 2, and I get 0.30 Teslas. So yeah, this is a graphing type question. Ideally, we would do a lab like this in the classroom, but for obvious reasons, we can't. But the process of this graph, again, is still the same. We need a relationship. And so we need to look at, okay, what are we actually measuring here? So we're measuring the force of gravity with a scale, and we're manipulating the current. So that thing we're measuring is the magnetic force. What do we have for equations? Well, the force of gravity is mg, and we know we're dealing with the magnetic force in this equation using ILB. Once we have that and we have our data, we put it in slope-intercept form, then we can forget about what our y and what our x is and use our slope to determine something about the universe. In this case, it's the magnetic field acting on the wire.